And I think you should actually give yourself a round of applause because you're still here for the last set of sessions of the talk. Because I know lots of conferences, people leave, they want to get home, but the fact you're still here says a lot about this conference. So I'm excited to be here and share this talk with you. So about perfecting your profiling skills. So a bit about me first. I've got 4 kids and 2 dogs. So life is pretty busy. So as well as profiling code, there's definitely a bit of profiling life as well. But unfortunately, life is never as simple to profile. But there we go. So it was a great introduction. So yeah, I do work for AGGrid. So we've got a data table, and also we're launching charts. So if you haven't used us for either of these things, I'd really like you to try it out. Remember, we've got a completely free edition as well as the enterprise. But that's all I'm going to say about that for now, because you want to know about profiling skills. So this is what we're going to go through today. So we're going to look at the Angular DevTools, the Web Vitals extension, the DevTools performance panel, and then I'll give you some quick-fire hints from things that I've picked up while developing myself. Well, that was the talk 2 weeks ago, until the Web Vitals extension has been deprecated and now has been moved into the performance panel, so the real-time metrics view. So I've had to update some of my slides, and I'll tell you when that happens. But this is a really exciting change for all of you, because the Web Vitals extension, which is something which I wanted to share with you, had this really useful information, but in terms of its downloads and its use, was tiny. So more people had downloaded the Angular DevTools extension compared to the Web Vitals one. And the Web Vitals one is framework agnostic. So the fact that these metrics are now going to be so much more easily available for you is really exciting. So I'm really glad Chrome are making that change. But first off, let's start off with the Angular DevTools. So how many have you got the extension installed? Yeah, that's a good amount. How many of you have used it? It's good. So you haven't just installed it because you've been told to. So yeah, so the Angular DevTools gives us these capabilities to debug our code. And it works at quite a nice level, where it hides quite a lot of the complexity, but we can still get a lot of useful information from it. So I don't probably need to tell you how to use it. You'll see it in your, DevTools. When you open it, you go to the Angular tab, and then you can start recording these profiles. So this is something which I did for AGGrid. So I opened up the DevTools, did some scrolling, sorting, and what you can see is that we're getting a lot of change detection. And now every time you're doing one of these change detection cycles, code is running, and that's taking time. And so it's potentially slowing down some of the other things that you might want to do. So when you're scrolling, if there's lots of change detection going on, maybe this is going to delay when the next row is actually visible. You might get blank outs. And this will only be exaggerated if your user's PC is slower than yours. So that's something we always have to watch out for. So the DevTools here has clearly shown us that all this change detection is happening. But then we want to say, OK, I know it's all happening, but why is it happening? So what you can do is you can then go and click on each of these bars, and it will tell you the source of that. So one of the things that was happening a lot is that in AGGrid, we were having these mouse out events. Because when we move the mouse over cells, potentially you want to change the styles, you might want to change the focus. So these events are being fired. But what was happening is that every one of these events was then triggering change detection because of the way it was patched with Zone.js. So what could we do about it? And this is where, internally inside of AGGrid, there's a lot of asynchronous behavior. We can't just update everything and run everything synchronously, because you'll get a really kind of jerky, lagging performance. So we want to break up some of these tasks. And so we do that with a lot of asynchronicity. So I've kind of, with this code snippet, given a kind of rough pseudocode of what's happening. So we'll have these asynchronous functions. If it hasn't been scheduled, then we'll set a timeout and we'll flush them and then do a bit of work. But because Zone.js patches set timeout, this triggers a change detection every time. So what you can do is, once you've seen this is something called zone pollution. And this is in the Angular docs. So I don't know if any of you have already been aware of this or read it. But so the recommended approach then is to run some code outside of Angular. You might be thinking, why would we want to run outside of Angular when we're building an Angular app? Well, even within Angular apps, there's sometimes some code which it doesn't necessarily have to update the template. So you might be doing lots of other calculations or things which you can maybe run outside of Angular. And this is something which we can do with AGGrid. So we inserted this, logic, so that all these internal events and all this internal asynchronicity was now run outside of Angular change detection. And we can do this because AGGrid was taking control of when things are being displayed and doing all those updates. So what we can see here, the side effect of this, is that we were able to just cut away a lot of these change detection cycles. So don't worry so much about this being AGGrid, but if you see the same behavior in your applications where there's something which is triggering a lot of change detection, maybe you've got something in an interval or that's polling something and you don't need that to change or trigger updates into your application, then you can maybe run it outside of Angular. But just don't do it for everything. Because if you do then have code which is changing the value of on your template, say you've got a counter going up, if the update of that code has been run outside of Angular, then that value is not going to be updated. So again, if you start going down this route and then see templates not being updated, then that's something to watch out for. And another thing which came out after we made this change is that because AGGrid was not triggering all these change detection cycles, users or applications themselves had been relying on the fact that change detection had been triggered. So sometimes by making these changes, you'll then trigger or reveal other bugs in your code which were not visible before. So a good way of seeing those kind of things is if you make a change somewhere, nothing happens, and then magically a value updates. And that's because you've made the change in your, the model that's going to be displayed, and then something else has triggered change detection, which is then when that actually gets updated. But that's not the only way we can make our application slow. The Angular DevTools also changes the height of these bars based on how long that specific task took. So if you're going along in your profile and then suddenly you get this long bar, then you might want to click on it, and it will show you which components it's spending the time in. So you might want to then look for expensive calculations. Is there something you can memorize in there? Can you put in a custom pipe? Or there might be a really large component tree, which has to be updated. And I would recommend watching this video about optimization techniques if you want to go a bit deeper. It spends a bit more time talking about zone pollution, change detection, and these large component trees in a better way than I probably have done just now. Now, who is familiar with all the core web vitals? OK, so that's a lot less than the Angular DevTools, which is good. Then this is new, hopefully new information. So these core web vitals play a big role in how, Google analyzes and ranks your site, and it has a big impact on your search results as well. And it's a really good way of measuring, well, how nice is it for my user to interact with this website? So if it takes a long time to load up, or if it doesn't interact very well, which is the IMP one, or this CLS cumulative layout shift, if once you load something, is everything moving around? So there are different measures of how kind of good or how nice your site is to use. But if you have got an external-facing site, and search results are important, then it's definitely worth paying attention to these metrics. So the interaction to next paint was stable as of March this year. And it observes the latency of all click, tap, and keyboard interactions. So a low score means that whenever the user is making an action, they get some instant or really quick visual feedback. So it's not about how fast your data loads or processes some data. It's more like when the user clicks something to say start processing it, they immediately see the website say, yeah, I'm processing it. Or if they're typing, they see all what they are typing appearing, and it isn't all like jumpy. So as I say, I was going to show you about the Web Vitals extension, but I don't need to do that anymore because that's deprecated. All you need to do is open up your performance panel in DevTools, if you've got Chrome version 129, and you'll now have all these metrics there available in real time for you to measure the local performance of your site. And this is where sometimes you'll need to compare your local stats against the real-world data, so like they call it crux. But that depends on how much your site is used or if there's that data available. But it's a really good move having this here in the DevTools because you'll all just have it and you can start using it. So here's an example so this is using the old extension, but the workflow is still the same. So you'll open up your performance panel and you'll start interacting with your website. So you don't have to start recording a profile or anything. You'll just see these interactions pop up. So here I was doing a test on our site on one of our examples where I'm typing in this external filter and seeing it filter the rows. And what you'll see if you've done bad code, which we had done on this example, is that you're getting all these red kind of markings of like saying, well, this interaction is really slow. And you can see in the filter, you don't see each individual letter press. There's this kind of jerking, and then the whole word appears. So this is a really bad kind of experience because the user doesn't know, have I actually typed all these letters? And that's why we're getting this red interaction. So this is a classic case of, well, yes, you've got to debounce the filter input. We don't want AGGrid to be doing the expensive filtering on every single key press, and we don't want it to be doing that synchronously. So by debouncing the filter input text, we're giving the browser the ability to paint those letters before we do the expensive calculation of, well, now let's filter everything, which is going to block the browser from painting for a bit. So that's like a relatively simple fix. But you can see the user experience and the IMP result, goes green. Because now you can see when they're typing, they're seeing all the letters, and everything is just feeling a lot more responsive. So we haven't actually improved the filtering speed of AGGrid here. All we've done is delayed when we actually run the filter to when the user has finished typing. But from the user's point of view, they're probably going to be thinking, oh, AGGrid has got a lot quicker. And there's a few different resources on how you can optimize IMP. There's a good article on WebDev and also on what are they called? Push-based. And if you just stay in the room, the next talk is going to dive into this even further. So it's a nice marrying of these topics. Right. Now, who's done performance panel profiling? Ah, nice. So the performance panel is definitely when you need to go deep and you need to start getting much more detailed. So potentially, one interaction has been flagged up as, this is taking a long time to do it. You've seen in your Angular dev tools, there's been that toolbar. So you kind of roughly know where you're looking. And so now we're going to dive into the performance panel. The performance panel has a lot more information into it. Sometimes it can feel potentially overwhelming, but I think one of these things is just try it out, and bit by bit you just get a lot more comfortable in terms of what you're seeing, how to interpret it, and then what you can do to start fixing some of these issues. So again, it's when you want to go deep, you find some individual methods And we'll also have a look at some forced layout issues. So to be able to record a profile, open up your site, go to the performance panel and hit the little circle. Now do the interactions that you want. So here I'm profiling our scrolling performance. So I did some scrolling, and then I'll save the profile, and then you'll get this profile in the panel. And I think we can go and explore one. Let's have a look. So here in the performance panel, you have this option here where you can upload a trace. So these are ones that I've recorded and saved before. Let's get this in. Right. So this is the flame graph. And this is showing us all the interactions and methods that have been called. So we can come up here and select a range, or just keep diving in and see all the methods from our code and how long they took. So this is from an old version of AGGrid. It's not too small. I'll start reading some of these method names. So we've got here, we're updating the column list, for each row, and then we're coming down the stack as the methods get called. And here we've got our cell component, and then in the cell component, we've got this method which is saying set inner HTML. And then we've got all these little blue boxes at the bottom, which is time taken parsing HTML. Another useful view, oh, not that one. Let's bring that back down. That I like to use a lot is this bottom-up filtering. So if I come out here, zoom out a bit, this will start listing all the methods and how long they've taken. So here we can see that a lot of the time we're spending when we're scrolling is in parsing HTML. And you can come in here and you can start not drilling down, but drilling up. Makes sense? So, the parse HTML is the end of this call stack. And that's been called from set inner HTML, and that was called from our cell component, which was called from our row component. So we have a rough idea of where we need to look to find this code. And as you can see here, the self time, it's saying of the currently selected bit of my profile, 37% of that time is being spent within this method of parsing HTML. So now we've identified which method it is that is taking all the time. So now we can say, well, okay, let's go and find that in our code base, and let's see if we have some other options. And in fact, we did. Come back here. So right within our, cell renderer, where we were just handling text, we were setting this string text to inner HTML. And now, as the name suggests, inner HTML supports, you giving it an actual tag, or you can have text which has, a div, and then the content, and the browser will parse that and then display it as the right elements. And so obviously that's got a lot more complexity to what we actually required. We were just wanting the browser to display some string content in the given element. So we switched inner HTML to text content, and we get this massive speed improvement. So you can see on the left where you've got all this blue, and that's like the rendering or loading. Which kind of disappears once we'd made this change. And there we go. Let's see that for real. So if I now load up a profile after the change was made, and zoom in, let's keep going in. Now can you see how it's just not there? In our bottom-up view, that's gone. And there's none of these blue bars at the bottom of any of these controls anymore. So then you can just repeat the process and say, okay, what's at the top next? Focus on that, and do this iterative approach until either you run out of time for how long you've got to profile the performance, or you've improved the performance enough so that any of the issues you had are no longer an issue. Another thing which the browser dev tools here are quite good for showing you is thrashing or forced layout. And this got an improvement in Chrome version 122, which probably is ancient by now, is that you can click on these purple bars. So you'll have this purple bar called Recalculate Style. And there's this very thin arrow. It's not blue like I've drawn on there, which you can follow back and find the reason why the browser had to recalculate the styles for your app. So what was happening here is that we added some new rows to the viewport while we were scrolling. And then we were destroying the old rows, and we were setting up some animation. Because it's a nice feature, say, if you sorted or you've moved some rows around, that you want them just to animate in and out rather than just appearing. So we had this logic, which was just when it destroyed a row, it worked out, OK, where do I need to position this row just off the screen so I can animate it? So the animation was querying the viewport to get that information. And then the browser was like, well, OK, you've changed the structure of the DOM because we'd put a new row in there. So I don't know whether this value is accurate or not. So I'm going to be forced to lay everything out so that I can give you that value again. So that's where we got this kind of loop. It's called thrashing or forced layout. There's lots of good, blogs and posts about this that you can go and find more information. But the fix in our case was that we added the new rows to the viewport. We can't get away from that. But when we were destroying the old rows and setting up the animation, well, this isn't a critical task that we know, to the pixel, the current viewport. It's good enough for us to use an old reading of the viewport. So when we read the viewport, we can cache it. And then for this animation, we'll just take that cache view. Because all it's going to do is maybe just slightly change the speed at which the rows go out because it's not quite accurate. But in a lot of the times, it's exactly the same. But because we're reading a cache value, the browser doesn't have to get involved. It doesn't have to relay out everything just to give us the value. So a common phrase is like, do all your reads before your writes. And so there's another link here to avoiding this in your applications. And now, in my last bit of time, I just want to give you some quick-fire hints of things that I found useful when profiling stuff. So there's probably quite a lot of NX users in the room, I imagine. And so if you do this, you can prefix the command with NX_profile, give it a JSON file name, and then run your task. And then if you take that file and upload it to Chrome, in the same way that I was showing you before, you can now view the tasks, and how long they take. So you can get this nice, view on saying, well, these are the dependencies, and also actually then it's this task which has taken a long time. It might say in your build or in whatever other task you might have in NX. But what if you then see a task in there which is taking a long time? How can you dig in and profile that? Well, that's where we can start using the node profiler. So you can do this. You can node -- inspect break, and then run your script. And then if you navigate to Chrome, / inspect, you'll get this node specific dev tools. So here I've found one of the tasks that was taking a long time, and I've run it with node and this inspect breakpoint. And then once you go to the browser, you can open up these dedicated dev tools. And that will now give you the opportunity to step through that task. So here I have enabled the recording a profile and hit F8, I think it is again, for it to continue. The task is now completed. I can stop the profile. And now I can use the same knowledge that I've done for the other things to dive into the performance of this node task. So this is an example of where we were generating a lot of the examples for AG Grid. But now I can use the same set of skills to profile a node task. And then once you've made a lot of your performance improvements, you're going to want to make sure that you keep them. It's very easy to regress on performance. So you might want to set up some benchmark testing. So there's a few tools out there, and if you're using vtest, there's an experimental feature that they've got there for running benchmarks. Also, you could use page web speed to monitor it. And then again, on web.dev, there's some good articles on this one is saying how to stay fast. So you'll find some more information there. And then this is quite an interesting one. You can also profile your types. So we use this, again, in AGGrid. We had a complex recursive type for, say, you've got a nested object, and you want to access data off it. Well, we want you to have some nice auto-completion when you're setting up your field. So you might have an address and then street, and you have to dive down into it. So we want to auto-complete at these nested levels. And because this type was recursive, there were potential for it to become quite inefficient and start slowing down your responsiveness in the browser. So archetype has this bench, and it can actually tell you how many different instantiations there are from your type. And using that, you can start tweaking your types and see the instantiation number hopefully drop, which will actually give your VS Code users or any kind of IDE better performance when using this type. And as I said before, there is so much good content on web.dev. So if you're not familiar with this site, I would highly recommend visiting it and just start clicking around, looking at some of these blogs and articles. There is a treasure trove of information in there that you can learn so much from. And it has really good examples and also actionable items that you can do if you do see any of these performance issues. And then, of course, don't forget the simplest way. You can also throw in a console log. Probably should add performance.mark here as another way, but hopefully that's enough to give you some insight and some hints on how you can profile your own apps. Thank you very much.